Hello students, I'm Dr. Tanmoy Biswas. I welcome you all in my YouTube channel TanmoyChem and Facebook page Chemistry the Mystery of Molecules. Today's topic of discussion is an MCQ and the question is in front of you. I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe we have tried, so let's start. Now, what is the best reagent for this conversion? So this alkene to this alkene. By the way, this alkene is endocyclic alkene and this alkene is exocyclic alkene generally. Exocyclic alkenes are comparatively less stable than endocyclic due to lesser substitution. But before going to the main topic, let's understand the concept associated with this problem. So addition reaction on unsymmetrical alkene with unsymmetrical addendum follows Markovnikov's rule. The negative part of the addendum will go and attach to that carbon which is poorer in hydrogen or less number hydrogen. That is the actual rule. And in this case, if you look at only HBr and peroxide combination can result anti-Markovnikov addition, I mean the opposite of Markovnikov. And generally, if you want to do elimination reaction, during the reaction, more substituted alkene is produced as major product. CSIR rule. Why? Because more substituted alkene is more stable. Also, that's why I told that exocyclic double bonds are less stable. Endocyclic are more. So obviously, elimination reaction will prefer endocyclic double bonds. And excessive bulky base prefer to abstract proton during this elimination reaction from less bulky carbon. Why? Because they are itself very bulky, so it is difficult for them to abstract proton from a more bulky position if available. Obviously, if I take HBr, NaOH, ethanol, so HBr means Markovnikov addition. So what should I get? Now, if you look at this carbon, there is no hydrogen at all, but there is one hydrogen. So according to Markovnikov's rule, I shall get this bromide. Now, next, sodium hydroxide, heat, and ethanol. So ethanolic NaOH will result elimination, but obviously now two options possible. You can say, sir, from here possible, from here possible. From where? So if you look at the elimination reaction will preferentially takes place which result more substituted alkene. That's stable. So obviously proton abstraction here and here will be preferred compared to this. So that's why this will result this one. But my target was this one, so leave it. HBr peroxide. So I shall get here anti-Markovnikov addition product. So opposite. By the way, there was hydrogen added. I have ignored. Right now bromine will add here. Now if you do elimination, so obviously from here hydrogen will come out. Beta hydrogen elimination, same enolic KOH heat. So obviously same thing, it will give same thing. Now if you say, sir, water catalyst, I mean catalytic amount of sulfuric acid in presence of water, it is a hydration reaction that also follow Markovnikov addition, so which will be here. Next place, concentrated sulfuric acid heat elimination reaction. So obviously it will result more stable alkene. First it will form carbocation and then more stable alkene. So this case also the same thing. Now if you look at the fourth option, it is HBr addition like the previous. So I get this one. After that, they give potassium tertiary butoxide and butanol. Now, if you look at potassium tertiary butoxide, it is this much bulky base. So in tertiary butanol, obviously in equilibrium, same base will exist. Now, for it, it's difficult to abstract this proton because this is secondary. Same is here. But if you look at here, this is primary. So there are 3 hydrogen. So one of them could be abstracted very easily because of the bulkiness of this potassium tertiary butoxide. It is bulky as well as very strong base. So it will abstract this proton. This will come and it will produce these exocyclic double bonds. So it's a special case where by using very bulky reagent, we prefer to get this exocyclic double bond. Now here why CSIR rule is violated? Because there is no option. The reagent is bulky enough. That's why it's difficult for the reagent to abstract this proton. Now what is the right answer? Obviously option D. Now if you get this question in your exam less than 30 seconds, how could you get the answer? Difficult, student. So whatever I have done, you have to do it in mind. For example, HBr, NaOH, so HBr bromine addition here. Now after that elimination, more stable alkene. So this will be the product. So not this, ignore. Now HBr peroxide here bromine. So elimination will produce again this one, ignore. Sulfuric acid here OH group. Now dehydration results same alkene, ignore. By the way, here double bond or here double bond, it will the same, doesn't matter. Now if you look at fourth option, potassium tertiary butoxide. So obviously now you can say, sir, when first, second, third negative, so obviously the fourth one will be right. I agree, but please do little more, 5 seconds extra. So this bromine potassium tertiary butoxide abstract proton from less bulky side, so obviously these will be the product. Now in chemistry nothing is impossible. From a more stable alkene you can have less stable alkene. From an endocyclic double bond you can have exocyclic double bond by this strategy. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.